China a făcut un pas major în domeniul energiei verzi, testând cu succes cea mai puternică turbină eoliană zburătoare din lume, un prototip asemănător unui dirijabil, capabil să genereze 1 megawatt de energie. Gigantul aerian, cu o înălțime echivalentă unui bloc de 13 etaje și o lățime cât un teren de basket, a fost testat cu succes în deșert și ar putea intra în producție de serie începând cu anul viitor. O bancă uriașă de energie este una dintre descrierile pentru turbina eoliană zburătoare S-1500, testată cu succes în deșertul Gobi de chinezi. Spre deosebire de turbinele eoliene clasice ancorate pe sol, turbinele aeropurtate plutesc în carcase umplute cu heliu, care ridică generatoarele în atmosferă, energia produsă fiind transmisă la sol prin cabluri rezistente.
You are now looking at the world's most powerful flying wind turbine, launched in western China. This enormous airship-like machine, roughly the size of a basketball court and as tall as a 13-story building, has just made history. Suspended high above the Gobi Desert in Xinjiang, it became the first turbine of its kind to generate 1.5 megawatts of electricity during a test flight. That is enough to power nearly 1,500 homes at once. And here's the part that has energy scientists stunned. This airborne giant is expected to generate far more power than ground-based wind turbines because high-altitude winds are stronger, faster, and more stable than anything near the surface. For decades, researchers have dreamed of tapping into this immense skyborne resource. Most called it impossible. Yet now, China's S-1500 has turned that dream into reality. For the first time, the sky itself has become a reliable, mobile power plant. And the machine leading this revolution has a name, the S-1500. But it also raises big questions. Could this flying turbine really replace traditional ground-based wind farms? Will its costs be lower, or could the advanced technology make it more expensive? And perhaps most importantly, how safe is it to operate a massive power plant floating in the sky? When you think of wind turbines, you probably imagine rows of tall white towers dotting hillsides or standing offshore in the ocean. These towers can be over 100 meters tall, their blades sweeping across an area larger than a football field. They're engineering marvels, but they come with limitations. At ground level, wind speeds rise and fall with the weather, the terrain, and even the time of day. Engineers know a simple truth. Power is proportional to the cube of wind speed. That means if wind speed doubles, energy output increases by a factor of 8. But at 10 or 20 meters above the ground, winds are weak and unreliable. Even at the tip of a turbine blade 100 meters up, the wind is still just a fraction of what blows higher in the atmosphere. Several kilometers above, winds are 2 to 3 times faster and dramatically more stable. This is the jet stream, a river of energy constantly flowing above us. For decades, scientists have looked up at those winds and asked what would happen if we could capture that power. The energy potential is staggering, enough to supply humanity's needs many times over. But building towers tall enough to reach those winds is impossible. That's where airborne wind power comes in.
Spre deosebire de turbinele tradiționale, modelul S-1500 nu necesită ridicarea unui turn sau o fundație clasică. Acest lucru reduce consumul de materiale cu 40% și costurile cu energie electrică cu 30%. Întreaga unitate poate fi mutată în câteva ore, fiind potrivită pentru deșerturi, insule și situri miniere, spun inginerii care au dezvoltat acest prototip. S-1500 are o aripă principală și o aripă inelară, care împreună formează un canal gigant. În interiorul acestui canal se află 12 seturi de turbine generatoare, fiecare cu o putere nominală de 100 de kW. Aceste rotoare captează vânturile constante de la altitudine mare și le transformă în energie electrică. Energia este apoi transmisă la sol printr-un cablu de ancorare.
China's S-1500 is the world's first megawatt-class airborne wind turbine system. Developed by Beijing Linyi Yunchuan Energy Technology, It represents a leap forward in renewable energy design. The machine itself looks like something out of science fiction. Measuring 60 meters long, 40 meters wide, and 40 meters high, it resembles a hybrid of a Zeppelin and a futuristic aircraft. At its heart is a massive airbag and ring-wing structure, creating a giant duct. Inside this duct sit 12 turbine generator sets, each rated at about 100 kilowatts. Together, they deliver 1.5 megawatts of power, making this not just an experiment, but a serious power plant in the sky. The S-1500 floats, using lighter-than-air gas tethered to the ground by strong mooring cables. But those cables aren't just ropes. They're lifelines. They hold the turbine in place and transmit the generated electricity down to Earth. This combination of flight and tether transforms the S-1500 into a floating energy station, anchored but airborne, mobile yet stable. Its maiden test flight took place in September 2025 at the Naomao Lake Base in Hami, Xinjiang, a region known for its harsh deserts and punishing winds. From September 19th to 21st, the S-1500 endured everything engineers could throw at it. Assembly under Gobi conditions, pressure maintenance, day and night strong wind release, and retraction tests. Against all odds, it succeeded. Energy scientists around the world were stunned. A concept long stuck in the realm of theory had finally left the drawing board. So, how does it work? At its core, the S-1500 is an airborne wind energy system. The idea is simple: float a wind turbine into higher, more powerful winds and harvest the energy. But making that idea real is anything but simple. The airship itself acts as the support structure, holding the turbines aloft. Inside the ducted body, wind rushes through at high speed, spinning multiple turbine rotors. These rotors drive lightweight generators, producing electricity on board. The power is then fed into a high-voltage transmission line woven into the mooring cable. This cable carries the current safely down to the ground, where it's converted and fed into the local grid or stored in batteries. Why go airborne? Because at 500 to 1,000 meters above ground, winds are much faster and far more stable than on the surface. On average, the energy density is 2 to 3 times higher.
Energia produsă de turbine este transmisă la sol printr-un cablu, o metodă inspirată de proiectele originale din 1957. În timp ce există îngrijorări cu privire la siguranța cablului pentru avioane, inginerii consideră că S-1500 poate fi utilizată temporar în zonele afectate de calamități, de exemplu, furnizând electricitate pentru operațiuni de urgență și salvare. Obiectivul următor al echipei este o turbină și mai mare care să opereze la 10.000 de metri altitudine, unde energia vântului poate fi de peste 200 de ori mai mare decât la nivelul solului. Astfel de turbine ar putea funcționa aproape constant cu un factor de capacitate apropiat de 100%, oferind energie regenerabilă fără a depinde de condițiile meteorologice.